Yeah, hello everyone. Yaoqi here. So I'm the founder of Altlayer. And at Altlayer, basically, we are building a decentralized interlayer for all the rollups. And on top of it, as you can see, right, we also have a product is a NOCO Dashboard, which can easily allow developers to launch rollups in minutes. And today I would like to share a little bit more of all the new updates and progress on our side. And I hope can also help everyone here to have a better understanding of the current rollup landscape. So as you can see, right, for the past 2 to 3 years, for the entire blockchain space, not just the Ethereum ecosystem, we have so many new development around this rollup tech stack. So as we can see, right, typically we have two categories for the rollups. One is we call classic rollup or smart contract rollup, like Optimism, Arbitrum, and all the different ZK EVMs. So for them, we have a full set of security guarantee and also the bridge and data availability guarantee from the Ethereum. As you can see, right, for most of these classic rollups, we launch like smart contracts on Ethereum to derive the security guarantee via the fraud proof or validity proof. And beyond that, we also have this trust minimized bridge. So that means compared to previous, either Cosmos, Polkadot, even earlier or different L1s, we have to have some layer-based bridges. But right now, for most of the classic rollups, we have native bridge, which also security guaranteed by the L1 via the proving system. And for all these classic rollups, right, it's quite straightforward to deploy. Like, as you can see, right, for example, the OP stack, you can quickly deploy the like sort of the L2 sequencers, and at the same time, you can deploy contracts on L1, so you can launch a rollup in just a few days. And beyond that, recently, we also have this new concept called sovereign rollup, which is proposed by Celestia. And compared to classic rollups, right, sovereign rollups basically, as you can see from the name, it has more sovereignty. So basically, you will have a group of nodes on the rollup side, and you can decide what kind of execution logic you want. So basically, you have more freedom to choose how many sequencers you want and how you execute these transactions. And on the other side, right, you have more ability to basically choose how you upgrade the protocol via the hard fork. Yeah. However, for these two types of rollups, right, gradually we figure out there's some sort of drawbacks for these two types of rollups. For the first one, as you can see, right, for the existing midnight version of a lot of these classic or smart contract rollups, typically we only have a single sequencer, like this Optimism, Arbitrum, and various ZK EVM rollups. So in that case, we may encounter some of these single point failure issues. For example, during the airdrop for the Optimism and Arbitrum, the sequencer was down for a few hours or even over 1 day. And beyond that, as the speaker just mentioned, right, there are also different MEV and also these front-running issues around this single sequencer, because right now you don't have many choices compared to a peer-to-peer network. Right now you only have a single sequencer. It's equivalent to a server, which can really control who run or execute the transactions compared to the other transactions. And beyond that, right, as we all know, there's another hard problem is about the upgrade. So for all the Solidity or the blockchain applications, it's actually the same as our traditional software, like our browsers or operating system. We all have like upgrades. We need to basically add new features, and sometimes if there are some vulnerabilities, we need to patch these vulnerabilities with some new code, right? So in that case, we need to have a proper upgrade system around these classic rollups. But right now, it's really controlled by some multi-sig wallet, and the developer need to propose the upgrade and then sort of directly leverage the existing contracts on the L1s to do the upgrade. So it's relatively risky compared to if we can really have a protocol level upgrade. Beyond that, for sovereign rollups, because you have more sovereignties of freedom, but at the same time, probably you don't really have the trust minimized bridge compared to the classic rollup. So you really need to rely on some other bridge providers and to provide the bridge across your sovereign rollups and the other L1s and different chains. And beyond that, compared to these classic rollups, for sovereign rollup, you also need to orchestrate the network a little bit. Like, for example, to get a bunch of these nodes or validators and to compose the L2 network. And after that, basically, you can set up the sovereign rollup. So the issue here is that you need to contact all the node providers or community nodes to join your network. And then, is it possible we find a way to address all these questions and issues and really get a better solution? Yes, there's another type of rollup we call enshrined rollup. Basically, as all the issues we just mentioned, right? They're either this centralized sequencer or this upgrade issue or even this minimized bridge issue. We can just enshrine all the proof system, bridge logic, and also including the data availability logic in protocol level. So it's sort of like we have all these logic previously written in smart contracts, but right now we make it into protocol. It's sort of like in protocol rollup system. And in that case, assume we have such enshrined rollup and together with the L1 protocol, which can help to enhance with all the logic, especially for the proving system into it. And as you can see, right, there are so many benefits we can get. The first one is really like the upgrade part. So instead of updating the contract with multi-sig wallet, relatively sort of security less, we can really have these in protocol level upgrade. Basically, different nodes can verify sort of the logic, and then later they can propose some EIP to upgrade the protocol. And beyond that, we also have these sort of protocol level security guarantee, basically all the logic, including for the bridge and also the proof system, right? Since it's baked into the protocol, then all the logic will be verified at the protocol instead of this contract level. And beyond that, as you can see, right, probably better performance, and we can also leverage the L1 nodes to become the sequencers for the L2s. In that case, we don't have the sort of the concerns around the single sequencer, and sometimes once the sequencers behave maliciously, we can directly slash these sequencers via this L1 protocol level security guarantee. But why this insurance rollout is so good, right? Why we don't have it right now? The biggest hurdle is still about the in-protocol changes. So as we just described, right, if we really want to have all these benefits, right, we have to have somehow changes on the protocol level. We need the L1 protocol to be incorporated with rollup systems to include the logic previously from smart contracts, but right now in protocol. For example, like the existing Optimism or Arbitrum bridge logic and also the proof logic, right? We have like tons of thousand lines of code in Solidity, but right now we need to find ways to write them in Go and directly into this Ethereum client. So that's a lot of work, and at the same time, we also need the consensus around the Ethereum community for such a huge change. So, but at the same time, is it a sort of a middle ground for us to benefit this enshrined rollup approach, but at the same time, without much changes on the L1 protocol? Yes, so that's sort of the stuff we've been working on for almost 2 years, and we really like to present to the community and also the ecosystem to use. It's called Beacon Layer. So on our side, right, we are proposing this called enshrined interlayer for all the rollups. As you can see, right, on the Beacon Layer side, it's like a decentralized sequencing verification upgrade protocol for all the rollups. So for the users, if they want to spin off a rollup, they can send a request to this Beacon Layer network, and then later the decentralized sequencer verifier will be assigned for the rollup to bootstrap this sort of the system. And at the same time, right, we have the full-fledged security guarantee from the L1s like Ethereum. So we have the fraud and also ZK proof on the Ethereum side, and also trust minimize bridge. For DA, you can also choose either you want Ethereum or Celestial or EigenDA. And roughly, the architecture is quite similar to the existing rollup. It's just like we have some extra load balancing system called aggregator. Because we want to handle millions of transactions and requests, so where the aggregator side, it will do the load balancing and split the traffic into different sequencers and verifiers for sequencing and verification. And beyond that, as I just mentioned, right, we also have the proof system on the L1 just to make sure like we really derive the L1's security. Okay, so into the details, right? What are the benefits or the components the Altlayer can, the beacon layer can really augment at the moment? The first one, as I mentioned, right, we have this decentralized network for all the sequencers. So this is just some pseudo code, right? So as you can see, a developer can just send some requests similar to this one to specify the settlement layer like Ethereum or DA layer, Celestia, and the VM. Either you want EVM or WASM, and at the same time, you can also specify the type for your proof system. Either it's optimistic or it's a ZK proof. And beyond that, the beacon layer will sort of handle all the orchestration for these rollup, and by selecting some sequencers from the network and then assign for the developer to set up the rollup. And the second cool part probably is also the first time we introduced for the ecosystem is the decentralized verification. So once we have a decentralized sequencer set, right, as I just showed you, basically we can have a relatively better security guarantee because it's a multi-sequencer compared to a single sequencer's like a single point failure. But right now, beyond that, the beacon layer can also doing some extra verification work. We call this proof of validity. So regularly, the beacon layer will check the correctness of the transactions and blocks proposed by the sequencers, and also do this quick verification on this beacon layer side. So in that case, now we have multiple options for developers, traders, and also users regarding the finality. So one, as you can see, right, on the sequencer side, we have this multi-sequencer. So it's relatively better security guarantee and the finality compared to the single sequencer. So at that level, we can achieve less than 2 second sort of latency. Beyond that, beacon layer provides this extra verification finality for you. And that's so-called like harder than soft finality. And it's also within minutes compared to the L1 level security. And beyond that, for some exchanges, right, they really want the L1 level security guarantee. In that case, we also have this fraud and the ZK proof. And just to make sure like the L1 also confirm the transaction or blocks are finalized on their side. And beyond that, it's also the first time for us to propose this hybrid proof model. Compared just this optimistic proof or the fraud proof, we also add these ZK components to snark or basically generate the ZK proofs option for some of the components of the fraud proof, and later you can verify on the Ethereum side. Beyond that, as I mentioned, right, upgrade is a big feature for a lot of protocols, and for us, we really like sort of introduce this forkless upgrade. So the developers and also the protocols, they can just generate the new binaries and new like features via the WASM, and later they will be passed across all the like protocol. And beyond that, we are collaborating with EigenLayer to introduce the restaking to the system because we have a full-fledged proof system, so we know how to do the staking and slashing. The details will be announced on Friday and probably next time on the Dev Connect. Okay, this is a very cool and decentralized protocol, right? On top of it, what are the concrete use cases we're building? The first one is sort of like this full-fledged or versatile rollup stack. You can choose different sequencer or DA layer and even interoperability layer you want, and you can also choose different types of rollups you want. And where our NOCO dashboard, you can quickly choose the parameters and launch it on this dashboard within a few minutes. And it's already live on the website. You can just try it out. And beyond that, we also help a bunch of projects already launch a bunch of campaigns, either for NFT issuing, either for these kind of events ticketing, like the football match in Malaysia. And beyond that, right now we have a very big ecosystem. So beyond like sort of the rollup stack we can provide for all the developers, now for any like sort of applications, especially gaming applications, like we are collaborating some big studios in the space and to help them to provide the fully on-chain game and also ticketing and NFT quest. Here I also bring this very interesting game. It will be included in our next campaign. You can just try it out. This one is our game-focused rollup. It's less than 100 milliseconds and zero gas, very high TPS. So for all the users or players, right, you can just try out this game. So every move is a transaction on-chain. So we just want to show that for fully on-chain game, we can really provide the same user experience without latency in this crypto-native world. And in the future, for all the users and the players and developers, you can just try out to build fully on-chain applications using our tech stack without concerning about the infrastructure provisioning. Yeah, that's sort of all the stuff around Altlayer. Just feel free to check out our documentation. And yeah, we would like all developers to try out our stuff. Yeah, thank you.